Hello, everybody, and welcome to week 4 of 1220 Online. Just a few announcements to start us off. Again, just let me remind you that you have web work and written assignments due Fridays at 11:59 p.m. I know there are some people who haven't been turning in web work or completing the full web work or haven't been turning the written assignment. You get 2 that are dropped, but if you keep on not doing that, you're not going to be successful in the class. So I do encourage you to make sure you get those web work and written assignments in Fridays at 11:59 p.m. Good. So that's the next reminder is that our first exam will be February 13th to 17th. So in that week. And again, you can schedule it in the schedule exams tab. And the practice exam will be available on Canvas the week before. And if you look back at last week's video, I discussed some other resources. One question I've been getting a lot for the exam is about calculators and a formula sheet. So I just wanted to mention a little bit about that. So you will be allowed to have a basic calculator, but it should not be programmable and not be graphing. So it should not be a programmable, so programmable or graphing. But like a basic calculator, you can compute like multiplication, division, logs, and so on is fine. Okay, and then there will be a formula sheet on the exam. You'll see it when you do the practice exam, but I also just copied it here since that practice exam isn't available yet. So it's going to have some basic trigonometric formulas relating different trigonometric functions. These ones are formulas you're also going to use a lot this week on this week's assignment. Then it has the derivative formulas for the inverse trigonometric functions, so you don't have to memorize all these, although of course it will help to have them at least be familiar. It has the definitions of the hyperbolic trigonometric functions, and then it also records like these basic trigonometric values like sine of pi over 6 is a half and cosine of pi over 6 is square root of 3 over 2. So those basic things that you sort of saw come, those basic values that you probably saw come up in last week's homework. Good. I also wanted to point out that solutions are posted for written assignments 1 and 2. If you go to the main page on Canvas and then just click the link for written 1 or click the link for written 2, then on that page where sort of there used to be just a link to the problems PDF and then the submission on Gradescope, now there's also a link to the solutions. And in general, for written assignment, solutions will always be posted probably a few days later after the due date. And then WebWork solutions, they always appear 1 hour after the deadline, just on WebWork. So if you're trying to get solutions to the WebWork problems that you missed or were confused by after the deadline, you can just go on WebWork and you can find what the solutions were. Okay, of course, they'll just give you the answer, it won't give you like all the work. The written solutions sort of show the work like you're expected to on the written assignments. Okay, so that's all the logistical information I want to convey this week. Let me tell you a little bit about what's going on mathematically right now. So we're starting chapter 7. So we just finished up chapter 6 last week. And now we're starting chapter 7, which is about techniques of integration. So we're taking sort of all these things, like all these new functions we've learned, like logarithm, inverse sine, inverse cosine, and so on. And we're going to sort of use those to use those and introduce some new techniques in order to understand how to compute a lot more integrals than we were able to compute before, especially find a lot more antiderivatives than we were able to do before. So section 7.1 just recalls some basic integration rules. It recalls all of the derivatives and antiderivatives we know so far. So like antiderivative 1 over x is ln of absolute value of x, things like that. And then it also recalls the method of u substitution, which you'll have encountered, for example, if you took calculus 1210, you'll have encountered that in section 4.4 already in the book, but it recalls how to do that. And on WebWork, there are a lot of example problems that are using u substitution just to get that fresh in your head. U substitution is probably the most used technique in integration, so it's really important to have it sort of down pat as a tool. Section 7.2 talks about integration by parts. This is something that, well, depending on your background, may or may not be a new technique of integration to you, but this is the next most important technique after u substitution. So again, this is sort of something we'll get a lot of practice with, especially on the web work problems, and so you'll hopefully have it pretty down pat after this week. One thing I wanted to point out, just to sort of help you organize like what concepts are involved in use substitution and integration by parts. Well, if you remember that sort of differentiation and integration are sort of like opposite procedures. Like you sort of take the integral of a derivative, you get your function back. So that, and some of these rules also sort of correspond to like a rule on differentiate, and for differentiation sort of matches up for a rule for integration. So sort of the chain rule in differentiation is really sort of the same thing as the use substitution technique in integration. Those sort of match up under this correspondence. And the product rule for differentiation is sort of what gives rise to the method of integration by parts in integration. So sort of these techniques, use substitution and integration by parts. On the integration side, these are really coming from sort of these classical differentiation rules that you know well from 1210, the chain rule and the product rule. Good, so that's section 7.2. And then section 7.3 is computing trigonometric integrals. So these are integrals where sort of like instead of like the kinds of things we've been encountering before, where you have like lots of powers of x and sort of things built out of powers of x and so on in the integrals we've mostly been able to compute up to this point. Now we're going to have like powers of sine and powers of cosine and maybe like products of the two multiplied together. And we're going to learn how to integrate such a thing. This is where these trigonometric formulas are going to come up. It's like the double angle formula, the half angle formulas. These sort of come up when you're trying to give a good system for sort of reducing this integral down to something you can solve. And so this sort of sets up some examples and then sort of describes a general technique you can take to do like an integral that looks like this or some other similar kinds of integrals and break it down until you have an integral you can solve. I want to point out, and of course, trigonometric integrals, and they're a little bit laborious. I mean, you can get some complicated ones that take a lot of work to evaluate. So you might ask, why are we doing this? One reason is it's actually a pretty important thing. These integrals are like the integral of sine cubed x times cosine squared of x. This is a fundamental integral to understand, for example, in the field of signal analysis. So this is sort of the field where you sort of take information that you're getting, like maybe like from a radio telescope or like maybe from monitoring whales singing under the sea. You take that information, that sound, which you used to record as a sequence of amplitudes, and you convert it and you sort of try and understand like the fundamental waveforms that are giving rise to it. So some of these integrals are like when you set up the mathematical theory of signal analysis, computing these kinds of integrals ends up being fundamental to that. Good. So just to give you something to hold on to as you work through this somewhat laborious section of learning how to compute these trigonometric integrals, know in the back of your mind that what you're doing is actually sort of something of fundamental importance. Good. So these are the things we're hitting this week. We'll do the rest of chapter 7 next week. So that's 7.4 to 7.6, and that's covering just some more integration techniques. And I'll go over just a brief overview of what those are in next week's video. And then our first exam is the following week. Then that will be on chapter 6, which we just finished, and then chapter 7, which we're doing this week and next week. After exam 1, I just wanted to point out that the classes are going to take a more conceptual pivot. So this chapter, especially chapter 7, is it's very like, here's a type of integral, here's how you solve it, like learn this technique for solving this type of integral, practice it, and until you can sort of do it pretty quickly. So we're sort of learning how to like put together all these tools we have in order to solve like some different kinds of integrals, and sort of it's a fun little game, and it's interesting and sort of important to learn these skills. It's not super conceptual in chapter 7. It's really like, here's a type of problem, here's how you solve it, and you sort of just have to work through it and practice. The stuff we'll do in the rest of this class is really sort of more about understanding some bigger ideas, understanding some sort of interesting concepts as it sort of relates to sort of like adding together like infinite sums, and sort of trying to add together infinite quantities, or take sort of integrals where sort of like the limit, the endpoints go off to infinity, and try and understand what that means. So that's the theory of improper integrals and infinite series, and that's what we'll start after exam 1. Okay, that's all I wanted to say today. Have a nice week, and I will see you hopefully in office hours, or well, you'll see me in next week's video.